Hi everyone! Today we are going to be using trig ratios, sine, cosine, and tangent to solve for the missing side of a right triangle. That's our lesson objective for today. Please copy down into your notes our title. The title for today is using trig to solve for missing side. If you remember in the first semester, we did this with Pythagorean theorem where we had two sides and we wanted to find the third one. Today we're going to have one side, one angle, and we're going to use that information and use trigonometry to solve for the length of the missing side. Okay. Just like always, here's our daily reminders. Copy down what's in this box. The more you write something, the more you're going to remember it. Remember that here's the angle. Across from the angle is your opposite. The side that touches the angle is the adjacent. And the longest one across from the right angle is the hypotenuse. Before we start today's lesson, let's go back and review some of the questions from the assignment, from the previous assignment that we did not do so well on. Question number 14 asked, what is the tangent of angle Z? And their angle Z is labeled in red, okay? So as always, the first thing we have to do when we're doing these questions is label our sides, okay? We know that 34 is the hypotenuse because it's across from the right angle. It's also the longest side. We know that 30 is going to be the opposite because it's across from Z, and that means that 16 is the adjacent, okay? So if I want the tangent of Z, the formula for tangent we know is opposite over adjacent. My opposite here is labeled 30, and my adjacent is labeled 16. So my answer is 30 over 16, answer choice D. Now 30 over 16 can be simplified down into 15 over 8. However, this problem doesn't require it. Remember I said last lesson that sometimes it'll be in simplest form, sometimes it won't. So this one, the answer is just 30 over 16. We also did not do so well on question number 19. 19 says, what is the cosine of angle C? And angle C is labeled here in red. So again, that's my opposite. It's across from the angle. This is across from the right angle, so that's the hypotenuse. And that means 30 is the adjacent. I want the cosine of C. Cosine is equal to adjacent over hypotenuse. The adjacent side here is 30, and the hypotenuse is 50. 30 over 50, answer choice A. Some of the problem I think we're having, look at the average time, 21 seconds. That's not enough time for y'all to spend on these questions because I'm able to write on this triangle, you're not. It probably takes you 20 seconds alone just to draw the triangle. Don't take shortcuts, draw the triangle and label it. You must label it properly. If you mix up these side names, the answers are going to be wrong. There's no doubt about it. You have to label these correctly. Okay, let's go on to the lesson for today, where we're going to be using trig to solve for the missing side. Okay, look at this example here. Two things look different about this triangle and the one from yesterday, well, from last class. Here we have an angle, 53 degrees. We've never seen an angle before. Usually it just has a symbol, but now we actually have the angle. And then we see we have only two sides labeled. This one is not labeled. So I'm gonna give you some steps and I want you to write these steps down. Step 1 is to label the sides of the triangle. Label the sides of the triangle. And by that, we're talking about the opposite, the hypotenuse, and the adjacent. So across from the angle, that's going to be my opposite side. This is my hypotenuse, and this is my adjacent. Same as last time. Step 2, this one's a little different. Step 2, we're going to determine which ratio to use based on the given information. Determine which ratio to use based on the given information. So we're given two things, well, three things. We're given the angle, we're given x, and we're given 15. X is my opposite, so I have an opposite. 15 is my hypotenuse, so I have a hypotenuse. But do I have an adjacent? Is there anything on this adjacent side? No. So I'm working with opposite and hypotenuse. Which formula has opposite and hypotenuse? Between, let me give you some options for the steps. To be specific, I'm asking for, am I using sine, cosine, or am I using tangent? Okay, so which one has opposite and hypotenuse? Opposite and hypotenuse is sine. So I'm using sine. The sine of my angle equals opposite over hypotenuse. Step 3, write the formula. That's what I just did. The formula is sine of the angle equals opposite over hypotenuse. Step 4, substitute. Substitute. So sine of 53 degrees equals, the opposite is x, and the hypotenuse is 15. Step 5, simplify the left using decimals. So here we have sine of 53 degrees. We have to get a numeric value for that. So that's what I mean by simplify. Okay, so let's go to decimals. And I'm gonna type in, this is the wrong decimals. We don't want the calculator, we want the scientific calculator. So sine of 53 degrees. And you see here how my calculator is in degree mode. We don't want radian mode, we want degree mode, okay? So let's use 4 numbers behind the decimal. So 7986, 0.7986. Equals x over 15. Now we're solving for x. Step 6, our last step. Solve for x using, and we'll use Math Papa. Solve for x using Math Papa. So we're gonna type this entire equation into Math Papa, and it's gonna give us an answer. 0.7986 equals x over 15. (0.7986) equals x over 15. Calculate it, and I get 11.979. Is that a reasonable answer? I think it is, because if you look back at the triangle, the hypotenuse was 15. It's reasonable that this is 11.976. If it was more than 15, we know right away that can't be the answer, because the hypotenuse has to be the longest side. Okay, let's do one more. And I'm gonna leave the steps up there so that we can see them, okay? So in this one, label the sides directly across, that's the opposite. Here we have the adjacent, and that's the hypotenuse. Next thing here, determine which ratio to use based on the given information. So I'm given x at the bottom, that's my opposite. I'm given 14, that's my adjacent. So opposite and adjacent, that's tangent. So I'm gonna be using tangent of an angle equals opposite over adjacent. The angle is 67. So tan of 67 equals opposite is x over the adjacent is 14. Now we're going to use Desmos to simplify the tangent of 67 degrees. So tan 67 degrees equals 2.3558. 2.3558. Bring down the right side, x over 14. Now we're going to put this whole thing in Math Papa. Two 0.3558 equals x over 15. I don't know why I'm typing so crazy today. Let me just make sure that's right. Oh, nope, it's 14. Good thing I checked. Oh, they gave y'all the wrong answer. Okay, so 2.3558 equals x over 14. Calculate it, and my answer is 32.9812. Why did I put 13? 32. My bad, y'all. 32.9812. Is that reasonable? I mean, this one's 14, this one's much bigger, it's 32. But again, these things are never drawn to scale, so we just don't know. We don't have the hypotenuse here to gauge, so we really can't tell, but that's the answer, 32.9812. Okay, so again, keep these steps in front of you, follow these steps, label the sides of the triangle just like we've been doing, determine which ratio you have based on the given information. If you only have the opposite and hypotenuse, you're using sine. If you only have the adjacent and hypotenuse, you're using cosine. If you only have the opposite and the adjacent, you're using tangent. Write the formula, substitute what you have into your formula, simplify the left. You must simplify the left. Math Papa cannot work with trig functions. You have to simplify the left using Desmos, and then move on to step 6, solve for x using Math Papa. You could solve for x by hand, cross multiply, but always please check your answer using the Math Papa equation solver, okay? Enjoy your day and good luck on your classwork.